All right, so hi everybody, I'm Chelsea Samuelson. I'm the head of operations at Loamist. I'm going to be talking to you guys a little bit about some software tools that can support with the process of site identification based on, a lot of the factors that we think about when seeking to utilize biomass, especially from distributed resources. So I wanted to kind of start by just getting a lay of the land. We got a diverse set of folks in here, all enthusiastic about biochar. So who is a biochar producer? Nice, nice, nice. Aspiring biochar producers. Nice. Buyers. Any buyers in the room? Always a hot topic. We got one in the far back, everybody. This guy in the far back is a buyer. Maybe a service provider for the industry, okay? Blended, I like that. You make biochar and service the industry. What other type of people are in the room? Who did I not call? Oh, sorry. Shouldn't have forgotten that. Anybody else?
Yeah. Foresters.
Foresters. We love the foresters. Landowners. Loggers. Sorry, you, sir? Forester. Okay, great. I think we got a pretty good lay of the land now. So I'm Chelsea Samuelson, as I said. My background is actually, I'm relatively new to the world of all things biomass. My background is in startups. I have been in operations on founding teams and been an investor. And I basically got incredibly enthusiastic about the idea of both stewarding and proper utilization of natural resources as a pretty, accessible lever to handle changing climate demands. So I'm going to talk to you guys about what our company does and what we're up to, why you should care about artificial intelligence in your biochar business and beyond, and what you can do now that you couldn't do before based on kind of how technology is evolving. And then I'm going to give you guys, we're working with Frontier on a biomass sourcing case study, which directly addresses some of the questions that were just being talked about. So I think really kind of interesting way to round out the session. I'm not going to do a demo today, but if anyone wants to see one, I'll give you my card and we can set up some time. Okay, so Loamist is a geospatial intelligence platform. We were founded in 2022 with the objective and the mission to increase the utilization of waste biomass. So we've kind of transformed as a company over time, but we have two key products. One is a product called Explorer, and it's a mapping tool that helps you map biomass availability on top of counterfactual risk, on top of kind of sustainability standards that you're looking towards. So I'll show you some visuals of that in a minute. And then we have another tool called Validator, which is a chain of custody tool. So it helps teams track at the individual load level what material is moving and then verify against a set of standards. So you have to meet XYZ criteria. You have to source from this specific location. The software can automatically go in, validate and verify that and pull up the exemption. So something's outside of what it's supposed to be, you can take a look at that and not have to review everything at one given time. We, through the website, we've tracked over 1 million tons of biomass. We've deployed over $4 million in reimbursements to teams, disbursements, and we're very excited about biochar. I think there's a ton of opportunity here, and I'm really excited to see everyone in the room working on this. So we're talking about feedstock for the most part here today, or at least what we're talking about. There's a lot of challenges when you're working with distributed feedstock. Point source feedstock solves a lot of this, although not all of it. You've got biomass all over the place with not a lot of visibility into the volume of material that is available or will be available, the price of that material, the material consistency and the characteristics, and then how it's moving. And then on top of that, you have kind of compliance and reporting burdens that are mixed in with the rest of whatever production you're pulling together, and a desire and a requirement to meet sustainability standards. So we build in this missing network for biomass feedstock data and tracking. And essentially, this is me attempting to break down kind of the fundamentals of what the tool does. We can take messy data, so we can take an ERP export or an Excel sheet or a bill of lading, and we put it through an engine, And then out the other side, we can extract specific information and fields from those documents, but we can also organize and manipulate that information into reports that can be automatically submitted to different entities, to dashboards that can allow you to play with or manipulate that data. And we do that through 3 key tools. So we use artificial intelligence as one of them. We use geographic information systems as another, so GIS, like maps, like Google Maps. And then we use deterministic analysis, which is our rule-based engine, and that's basically predictable problems. So like simple math, we can say to the system, you're looking for an origin, geographic coordinates that start within this specific polygon origin. And if something does fall within those parameters, we can give it a check mark. That's deterministic analysis. So specifically for this industry, we can track material movement by load, by vendor, by company, by time frame, kind of any parameter that's important and traceable, we can track against it. We can validate different characteristics of that material and then provide compliance-ready reporting. We are not an MRV solution, though. I'm going to actually skip through these and move to this, which I think is probably, the most relevant topic of what we're sharing. And so this study, the origin of it was that we wanted to do basically there's just a lot of sticky problems in people, both clarity and understanding the sustainability standards that are being required. And then there's just actual operational stickiness in understanding those. There's so many variations of how these projects come together and the unique dynamics of a geography and a material. So the goal was to say, all right, let's put out a theoretical case study where we ask questions to determine counterfactual, market, and sustainability risks in a given geography. So if we've selected a site, what is the risk that site is or is not a good location for my facility? So we're working with a fake company, Acme Biochar. They want to produce 10,000 tons of biochar a year. They're located in the west part of the United States, and they need to figure out, where's a good spot for me to site my first location. We're working this is a greenfield facility. We're new. We are in the west, but we're we don't live in a specific city in Oregon. So they need to figure out where are the biomass islands, which I will explain to you in a minute. How proximate are they to public lands? What volume of residuals are available? And how proximate are competitive uses, to answer some of the first and critical key questions. I don't know what I did. I broke it. I can just use this. No, I think I really broke it. Oh, there we go. I'll try again the next slide. You can come fix it when I don't win. Okay, so biomass islands, optimal locations that minimize the utilization, counterfactual, and market risks. So this is a map of the biomass islands. Now, what is a biomass island, do you say? So what we did is we went and looked across the country at all sawmills and their production data and estimated a residual amount from those sawmills. That wasn't me. I did not do it. So I'm gonna keep talking. Oh, okay, I don't know. So we looked at all the sawmills, and then we said, all right, within a certain geographic parameter around these, how many competitive uses are there? Who is sourcing residual material for things like pellet mills, pulp mills, biomass to energy conversion facilities? Those are some of the big volume consumers of that material, and if they're in the competitive landscape, you'll be displacing the use for that material previously. So that's a problem. So we do not want them in the radius. We do want some amount of residual production from the sawmill. We do not want the competitive uses. Not saying that those three things are the only competitive uses. There's animal bedding. There's lots of different ways that sawmill residuals can be used. So we looked at those, and we were able to, and then we overlaid that against public lands data and forestry activities happening in the west part of the United States. And the combination of those two parameters allowed us to narrow in on two locations, one of which is Flagstaff, Arizona, and the other is Lakeview, Oregon. Yeah, great. Can you go back one? Yeah, okay, so this is what we were just talking about. So looking at just the west side of the country, you can see kind of the public lands data, and the overlapping density ended up coming out at Lakeview, Oregon, and Flagstaff. It's working again. Great job, thank you so much. And so putting then a 50-mile radius around the pin of Lakeview, Oregon, we're able to, the software can show there's 90,000 tons of mill and forestry residuals in the area. A large chunk of that is coming from a single mill, so obviously a critical stakeholder in the piece of the puzzle and would need to be spoken with immediately. But you can then overlay that against a larger radius of where's the competitive landscape in the area. So this then shows where those pellet mills, the pulp mills, the biomass energy conversion facilities are located. Software can do a distance analysis of those and then pop out a table which essentially says, here's your competitive facilities, here's how far away they are, here's the price of transportation to get to each of those, so you can show whether or not they're an economic alternative to what you're suggesting. And these are like really important considerations when thinking through the counterfactual, which then becomes incredibly important to proving that you're additive, you're not displacing anyone from the existing industry, and you can go after those carbon credits, which, as we can tell in biochar, are a fundamental component to making the economics work for any given facility. And that is high level what we're up to in some of the work that we're doing. We essentially designed these tools to help us understand what was happening in the biomass world. So this GIS tool we have has over 200 layers of biomass-specific information that can be queried, from what I was just sharing with you to the entire railroad network and nodes across the country, to Class 6 wells, to information about air permitting districts and their friendliness, California, and information like that. So we're always looking for kind of pilot partners to continue to validate and test our software. So if people are looking for solutions like this, please be in touch. And that is it. I'm open for questions.